Okay, so what we're going to do today is we're going to take a look at degrees and radians and maybe talk a little bit about the purpose of both of them. Most of us have learned degrees first because degrees work really well with geometric shapes like triangles and pentagons and hexagons and things like that. But radians work a little bit better for things like trigonometry. Sometimes it doesn't really matter whether you use degrees or radians, but you do have to make sure that your calculator is in the right mode. It needs to be in the mode of your choice. So I see degrees and radians as kind of being like Fahrenheit and Celsius and things like meters and feet. They're just different systems, and the different systems lend themselves to different applications at times. So let's begin. I'm going to take a look at this unit circle to start off, and I'm just going to go around the circle a few times and put some of our special angles, our more famous angles, as we go all the way around. Of course, you know that all the way around a circle in degrees is 360 degrees. We're going to start at 0. Something about the unit circle is that going in a counterclockwise direction is positive, and going clockwise is negative direction, and we're talking about angular direction. All right, so let's go ahead and start marking off approximately where all the 30-degree angles are. So like if I continue to add 30 degrees to each of those hash marks, it'll look something like this. So we start with 30 degrees. And 30 plus 30 is 60 degrees, right? And then plus 30 is going to be 90 degrees, or what we call a quadrantal angle. 90 plus 30 is 120 degrees. And plus 30 is 150 degrees. Plus 30 is 100, whoops, let me put it here, 180 degrees. Continuing on, we get a 210 degrees, 240 degrees, whoops, 270 degrees. And then plus 30 is 300 degrees, 330 degrees, and finally 360 degrees all the way around. So we call this coterminal when a 360-degree angle is the same thing as 0 degrees. So those are going to be our 30s, 60s, and 90s. As we go all the way around the circle, those are special angles, and each of these larger angles, like quadrant 2, the 120, the 150, 180 are in quadrant 2. Maybe I'll put the quadrants here as well. And then we have quadrant 3, has the 210, the 240, and then quadrant 4 has the 300 and the 330. So these are all 30-degree and 60-degree, and then even the quadrantal angles, the 90, the 180, the 270, and the 360 are called quadrantal angles because they are right on the dividing line of the quadrants. So let's take a look at another special angle, 45-degree angle. And so I'm going to put this in red, 45 degrees, and I'm just going to continue to count 45-degree angles. 45 plus 45 is 90. I've already got that one written. And plus 45. 90 plus 45 is 135 degrees. 135 plus 45 gets us to 180. And 180 plus 45 is 225 degrees. 225 plus 45 gets us back to the 170, or 270 that is. And 270 plus 45 is 315 degrees. And then of course we add 45 more and that gets us back to 360. All right, so those are our 45-degree angles. The 45, 135, 225, 315. 45-degree angles are very symmetric because they're right in the middle of each quadrant. 45 is right down the middle of quadrant 1, 135, right down the middle of quadrant 2, 225, right down the middle, quadrant 3, and then finally the 315, middle of quadrant 4. All right, so what I'm going to do now is switch gears and we'll talk about radians as we go around the circle. And I'm going to start like this. I'm going to start by counting off pi over 6s because I know that pi over 6 is a 30-degree angle. So I'm going to start counting around. So we've got pi over 6. And then if I continue to count to this one, that would be 2 pi over 6. Let's mentally reduce that down to pi over 3. So 1 pi over 6, 2 pi over 6, 3 pi over 6 is really the same thing as pi over 2. And then let's see, 1, 2, 3, and then we go to 4 pi over 6 is the same thing as 2 pi over 3. Wait, 1, 2, 3, 4, and then 5 pi over 6. Over 6 is right there, and then 6 pi over 6 is going to be 6 over 6 is 1. That's going to be pi. All right, so that's like 6 pi over 6, and then we go to 7 pi over 6. You do need to use fractions for the radians. Fractions come in very helpful. 8 pi over 6 would be the same thing as 4 pi over 3. And then what do we got? 9 pi over 6 is going to be 3 pi over 2. 10 pi over 6 is 5 pi over 3. And then what are we at? 11 pi over 6, 11 pi over 6. And we add one more pi over 6 to get 12 pi over 6, which will mentally reduce to 2 pi. All right, so that is going to be the whole set of basically 30s, 60s, and 90s. So something that we'll point out is all the ones with the 6 in the denominator are all going to be associated with 30-degree angles, like pi over 6. And we go over here, 5 pi over 6. Well, I'm going to say that 150 degrees or 5 pi over 6 is like a 30-degree angle, but in quadrant 2. And then this 7 pi over 6 is, call that a reference angle. The angular distance back to the x-axis is 30 degrees or 1 pi over 6. It's like a 30-degree angle. And then all of the pi over 3 angles, well, they refer to like 60-degree angles. Pi over 3, the 2 pi over 3 is 120 degrees. And if you take 180 and subtract 120, you realize that that is actually a 60-degree reference angle. And then continuing on, 4 pi over 3, 240 degrees minus 180 is a 60-degree reference angle. So the nearest x-axis is where I'm going to measure that to. And then finally, the 5 pi over 3 or 300 degrees is going to be 60 degrees away from the 360 right here. 60-degree reference angle. All right, what about What about the 45-degree angles? Well, those are all going to be pi over 4. Pi over 4 is the same thing as a 45-degree angle, or maybe I should say pi over 4 radians is the same thing as 45 degrees. So I'm going to start counting in pi over 4s. So 1 pi over 4, 2 pi over 4. We'll reduce that to pi over 2. It's already there. 3 pi over 4. 3 pi over 4 is in quadrant 2. 4 pi over 4 is going to be the same thing as pi. Jump over here to 5 pi over 4. And then we go to 6 pi over 4. Down here is the same thing. Reduce it to 3 pi over 2. 7 pi over 4. 7 pi over 4. Just continuing to count pi over 4 degree angles, or pi over 4 radians, that is. And we go 7 pi over 4 plus pi over 4 is 8 pi over 4. 8 divided by 4. And we're back around to 2 pi. So this is the complete unit circle. Like those are all of the special angles, at least. There are a lot of other possible angles, but those are all special angles. Now, what I'm going to do is point out that each of these degree and radians show places where they are equal. 60 degrees is equal to pi over 3. Pi over 2 is equal to 90 degrees. And let me scoot on down here, because this is like what we often will use for conversion. We're going to say that pi is equal to 180 degrees. But each of these hash marks represents equality. So that takes us to, well, what if we don't have a special angle? Or maybe we do have a special angle, but what if we want to do some converting? So I'm going to go ahead and switch gears now. And I'm going to do some conversions, and I'm going to use something called dimensional analysis.
Something that maybe we would have learned in, is that spelled right? I think so. Analysis. Hopefully that's right.
A way to convert so that we can remember, do we multiply to convert? Do we divide? Or what do we do? So the reason it works is because we're going to set up our units so that they will cancel. So let's start with 36 degrees. I want to turn that into radians. So here we go, 36 degrees. And I'm going to put it as a fraction. We can always write a fraction if we want to. And then I'm going to put my conversion here. And the conversion I'm going to use is pi is equal to 180 degrees. And I can make a fraction out of that. And I'm going to put 180 degrees here. And I'm going to put pi in the numerator. And what that allows me to do is it does allow me to cancel the units of degrees. So I cancel the units of degrees. And I call this the one trick, because actually pi is equal to 180 degrees. Pi radians is equal to 180 degrees. So in a sense, if we put the same thing in the numerator and denominator, they are equal. It's kind of like multiplying by 1. I'm going to call this the one trick. And the one trick works because we're basically multiplying by 1. And when we multiply by 1, we aren't changing the value of anything. So I'm going to start by multiplying. Let's see, that's equal to 36 pi over 180. And then we can continue from there, and we can reduce. You know, like we can say that this is 18 pi over 90. And we'll keep cutting it in half. It's a 9 pi over 45. And 9 goes into 9 once, and 9 goes into 45 5 times. So we're finished with pi over 5. So pi over 5 radians. Pi over 5 radians is going to be a first quadrant angle. Going to be somewhere around here, just like the 36-degree angle is, a little bit bigger than 30 degrees. So pi over 5 radians. All right, moving on. I'm going to take 196 degrees and convert this into radians. And I'm going to use the same conversion. I use the same thing over and over again, but I'm going to divide by 180 degrees so that my degrees will cancel. So I have 196. The degrees have canceled. Pi over 180. And then I'll just go ahead and reduce that. Well, it reduces down when I cut them in half to 98 pi over 90. And we can cut them in half again, and that's 49 pi over 45. And that's completely reduced. Now I can tell this is in quadrant 3. And the reason I can tell it's in quadrant 3 is because I know that 45 pi over 45 would be right here. 45 over 45 would be 1 pi, but this is going to be an additional 4 over 45 pi, or 4 pi over 45. And that's going to get me into quadrant 3, which is right here. All right, let's convert in the other direction. Pi over 10 radians. So pi over 10 radians, already a fraction. So what I'm going to do is multiply by 180 degrees in the numerator over pi radians in the denominator. And you can see what's going to happen here. The pi's are going to cancel. And we're left with 180 divided by 10, which is 18. I still have my degrees. They have not canceled. It's equal to 18 degrees. And of course, an 18-degree angle, like pi over 10, is going to be in quadrant 1. 18 degrees would be that reference angle. Okay, one more. Go to 3 pi over 5. 3 pi over 5, and I'm going to multiply again by 180 in the numerator, 180 degrees over pi. And I do know that the pi's are going to cancel, and I'm going to have 3 times 180 degrees over 5. And that's going to be, well, we can divide by 5 first, or we just do 3 times 180 and divide that by 5. And that gives us a 108-degree angle. And where would that one terminate? Well, I know that 108 degrees is less than 180 degrees. So I know it's going to be less than that line right there at 180 degrees. And it's going to be in quadrant 2. So it's going to go to 108 degrees. And then 180 subtract 108 gives me a 72-degree angle right here. So my reference angle will be 72 degrees, because 108 degrees is going to be exactly 72 degrees away from the x-axis. And that's it. I've probably given you a bit more than is necessary. but I'm trying to fill in some gaps because as we learn about different conversions, we're going to start learning about reference angles and quadrants and radians and degrees and all of that. So hopefully this was helpful.